Okay. Last class we have discussed circuit diagram, a differential instrumentation amplifier using a transducer bridge. We have taken two op amps in the voltage follower. We have bridge circuit and we have a differential amplifier. These things in the previous class, all of you have copied the circuit diagram, and also I told the voltage follower we are using in this particular instrumentation amplifier. The reason also I told, to avoid the loading effect. Basically this op amp acts as a buffer. This op amp does not allow to load this particular bridge or this particular circuitry. So hence we use these voltage followers so that we can avoid a loading effect. Again, somebody may ask what is the loading effect. We have a separate video for that. You people can go through that video. And coming to only the bridge. All of you have studied already this bridge in your previous semesters. Your bridge is balanced, I can say, whenever voltage VA equal to VB. So I can say bridge is balanced, or VB equal to VA. What's the equation, for example, for VB equal to? Can you type in the chat box? VB equal to, consider only this part. Hope it is visible to you people. Consider only this much and write down VB equal to in terms of RC, RB, VDC. In terms of RC, RB, VDC. I want a VB. Can you try in the chat box, any one of you? Otherwise I'll show you, no problem. And equations are written many already. I hope at least one or two students can type, maybe wrong also, so that I can see their names. VB voltage equal to. So applied is VDC. One resistor is RC and there is a RB. I want VB equal to. Can you type the answer in the chat box? You should come forward, otherwise remember what all you are doing now, how you are behaving. Later you have to recall. So let me show you the answer so that you can finish the portion fast if there is no interaction. Very good, Rohit, thank you. Whether right or wrong, first of all I thank you for typing the answer. And Kirti has typed RB into VDC divided by RB plus RC. Thank you. Maybe answer is wrong, no problem for me. Answer may be wrong, but you are coming forward and you are sharing your whatever is there in your mind. That is very important. Unless we come to know what is there in your mind, we cannot explain more. Anybody else? Only two students are there in the class. Remaining 45 are statues. Simply they are kept on and they are moving here and there, I think. Pavan, Preeti has typed. Okay, that shows a network analysis. Most of you have failed. Hardly 3 students have passed. Other students might have, even though they might have got pass, but they don't deserve to pass if this is the answer. VDC by 2. Ganashri, thank you, but VDC by 2 when RC equal to RB. Siddhartha, VDC by RB plus RC. Okay. And now few students, they are typing the answer. Pooja Patil, Pooja Kotabagi, and many people. Manjunath is typing VDC divided by RC into RB. I am so scared about you people. If you join any core company, it's the most dangerous. Even including LIC, I had taught this. How to find out voltage across the resistor. RC plus RB divided by RC. Okay. Very strange answers. I never expected such answers, because in my class also, previous class, we have discussed, and even network analysis most of you have done it. Anybody want to explain this? I'll give the chance. Okay, I think Sneha, can you come forward and explain? I'll mute my mic. You please explain. Come forward, Sneha. Even if you don't want to switch on the video, leave it. Switch on the mic and explain. Or Pawan. Sneha, even if you unmute and tell, I'll be happy to listen your voice. I can do it, but it is an opportunity for you. Even you can just tell, unmute the mic and tell. Pavan, Sneha, come forward and tell. I'll be there with you. Even if you tell wrong also, I'll be happy, because I could be able to listen your voice. Sneha or Pavan, can you tell in general, or how to do it, how you got? Unless you interact, classes will be over within few days. All portion will complete. Then it's dangerous for you people only. You come forward, Sneha and Pavan. Unmute your mic. I'll mute my mic. Anyone of you explain? No problem. All are friends only. In the class, usually you tell. Anyway, if they don't want to come forward, I'll tell you what those two students have told. RB divided by total resistance, RB plus RC. This is total resistance. RB and RC together is a total resistance. So RB I want across. RB divided by total resistance, total voltage applied. This is a VB equal to VA. VA equation I have written. That's all. These things you have studied in detail in your UG already, previous semester. And you please cross verify what all of you have written VB equal to. Now, just I will rearrange. Simply I will take RA plus RT. This is a RT. This is a RC, RB, RA. This is a VA. This is a VB. So, VB equal to VA. I am rearranging. This side I am taking a RB plus RC. This I am taking to this side. Simply I am multiplying. I am rewriting. And now, what I am doing? RA into RB equal to ZN. So this RA RB I'll cancel, and I'll rewrite the RB plus RT equal to RB into RT equal to RA into RC. This is what I am going to get in this slide. So take 1 minute, copy down the bridge and a few equations. Take a few more seconds and try to understand. We say bridge is balanced whenever VB equal to VA, VB equal to, I am writing equation, and VA equal to, I am writing, considering only it is RT as of now. We take a two possibilities. One is a RT, and the result is changing. Instead of RT, it will become RT plus or minus something delta R. A second case will take like that. Hope all of you have completed copying, so that we can go to the next slide. Okay. There is a change in the resistance of the transducer. Initially it was a RT, RC, RB, RA, bridge was balanced, say VA was equal to VB. Now there is a small change in this RT. So let us consider plus delta R I am getting. Why? A temperature has changed, because of resistance has changed, because of that now it has become RT plus delta R. Now let there be a change in the resistance of the transistor by delta R. Since RC and RB are fixed, these two are fixed. Therefore, this VB will remain same, but VA will change. So, I am writing an equation for a VA. VA equal to RA by RA plus RT I have written already. Same equation, but now instead of RT plus delta R, a small change is there in the resistance that I am considering, and I am writing the equation. VB will remain same, and VAB, I want a difference between these two. If I find out the equation, what I am going to write, VA minus VB. I will fill the VA value, I will fill the VB value in the next line. Now you copy down only this equation. And VB is there already in your notes. A previous slide we had a VB. What you are supposed to copy down is 2 lines, 3 lines. RTA has become RT plus delta R. And VA equal to, considering RT plus delta R, VB is as it is. VAB equal to VA minus VB. VA minus VB. As circuit is with you already in the notebook, only these 3 lines you have to copy down. I'll wait for another 5 seconds. Now, simply I'll fill those values. VA equal to RA by RA plus delta R plus RT into VDC. It is same, RB by RB plus RC into VDC. I'll just fill, I'll simplify, VAB equal to, I'll get it. So let me go to the next step. If I am assuming, if RA equal to RB equal to RC equal to RT equal to R, then the equation becomes VAB equal to RA divided by 2RA plus delta R and into VDC minus RB by 2RB. I am taking RC equal to RB, hence it becomes a 2RB. VDC I am keeping as it is. So next, what I do? RB get cancelled, and I will take a LCM, and I will write down 2RA VDC minus 2RA VDC for this, 2RA VDC for second term, and remaining is delta R into VDC minus delta R into VDC, and denominator will get a 2 into whatever is there, 2RA plus delta R. And what I do, I just simplify it. I will cancel these two like a minus A, then remaining I will write down minus VDC delta R divided by 2 into bracket 2RA plus delta R. Just copy it, 3 steps. The steps are very simple to understand, to rewrite, to remember. Only one point you have to remember, all resistance are equal to R I am considering, so that we can do the derivation, we can continue. With a simple steps we will get a equation. Let us understand this. 2RA VDC minus 2RA VDC get cancelled. VDC delta R divided by 2 into 2RA plus delta R I am writing. Total class strength is around 67, but 53 are attending. Again, nearly 10 students are absent. I think hardly 2 or 3 students they are attending, but 7 to 8 students they are told they are not getting a link. Then those students are absent today, and today after the class I want to talk to all those students before I try to add those to the Google groups. So I want them to talk to me after this class. So this is what we have taken from the previous slide. VAB equal to, negative sign indicates VA is less than VB because of delta R. This is a circuit which is there in your notebook. VAB is applied to the differential amplifier through the voltage follower to avoid the loading effect. Understand the VA, VB, VAB where I am applying to the differential amplifier. Just I am using two voltage followers. Try to understand this just to avoid the loading effect. It is nothing but VA is given to this point and VB is given to this point. That's all. To avoid the loading effect, we have used the two buffers. That's all. Now, the same equation. Now the gain is given by minus RF by R1 for a differential amplifier. I have done the derivation also. VAB is the input. Now VAB I am writing as it is. Minus RF by R1 is the gain. Now I am simplifying this. I am rewriting minus into minus will become plus VDC delta R divided by 2 into 2RA plus delta R. RF by R1 is as it is. Generally, delta R is very small compared to your 2RA. Hence, I can rewrite this as a 2RA plus delta R equal to 2RA. And 2RA into 2, it will become 4RA. Just I have written that equation. Now, we take a minute and copy down these three steps. I repeat, this is a equation we got, and meter deflection is directly proportional to the V0. V0 is directly proportional to the VAB. VAB is directly proportional to the change in the delta R. Change in the delta R is directly proportional to the physical quantity. Hence, I can say this deflection is directly proportional to the change in the physical quantity. And this is a basic concept used in most of the meter deflection. We say it is measuring temperature, but actually it is measuring a voltage or current, but indirectly it is measuring the temperature or some physical quantity. All meters will be like that only. We convert into electrical or quantity, then we do the measurement of that electrical quantity. We say we are measuring that non-electrical quantity. Now we are going to discuss about voltage to current converter. This unit will take very less time, but next 2 units will take a lot of time. Even though we have mentioned 8 or 9 units for both the units next what we are going to discuss, but those will take a lot of time. So try to understand why I have to convert a voltage to current. I have a lot of physical quantities, say temperature, pressure, motion, etc., etc. And a sensor I use. Sensor will convert a physical quantity into voltage. And whenever I connect these two, this is a terminal, to the processing or a display unit, there will be a lot of distance will be there. For example, sensing in the industry I am doing somewhere, controlling unit will be somewhere in some other room. If I simply directly connect these two lines to the processing, automatically the voltage will reduce. So this will not be a proper measurement of the physical quantity. And this video is already available in the YouTube. I don't know, somebody might have unknowingly seen, and I really sometimes feel strange. Present generation, what they expect. Anybody has seen this video? Voltage to current converter? Okay, let me go to the next slide. The same slides I used in the videos also, which I have uploaded. When sensor output is V1, when I connect directly to the processing or display unit, which is far away from the sensor, it will never be V1. It will be reduced. So hence, I convert this voltage to current because noise will not be affected. This current, usually voltage will be affected due to noise, and it can reach a processing or display unit without any much noise, interference, much effect it will reach. Hence, most of the time, we convert voltage to current conversion. And there are two methods are there. One is a voltage to current converter with a floating load, and there is a voltage to current converter with a grounded load, but grounded load is not there in the syllabus now. Explicitly they have mentioned a voltage to current converter with a floating load, but when you go for a gate exam and all will be there. You cannot say it is not there in our syllabus, sir. The gate people never ask whether you have studied or not. They expect you should know. Similarly, remember, industry people will also never ask whether it was there in your syllabus, whether your teacher has taught you, whether he has taught you properly. Those will never come. Whether that time your lockdown was there, nobody will ask those questions. Please remember, you should know the answer. Let us go to the next. So voltage to current converter with a floating load. Floating load means what, sir? load is not connected to the ground. In this diagram you can say this is the RL, it is not connected to the ground. Hence we call it as a floating. In another case we connect a ground to the load to the ground, but that case is not there in the syllabus. Now we will talk only about this. Input is given to the non-inverting terminal, and whenever I say this is a ground, this will be what? V1 is grounded, then V2 will be called as, anybody type, those who are active listening class. When V1 is grounded, V2 is called as, are you there in the class? Pooja, thank you, virtual ground. Thank you, Pooja, Ulvesh. A few students are there. I really happy to see them, and because of such few students, even teachers will be active. Even they like to take extra classes. They like to spend their time for the student community. Thank you all of you. Ephraim, I think, I don't know how many classes he has attended. But anyway, today he is writing some answer in the chat box. Now, when I say this is ground, it's a virtual ground. Now if it is a V1, this will be also equal to V1. That is a basic concept one should know. Now feedback voltage across the R1 drives the inverting terminal. Inverting terminal, I am connecting this R1, and this voltage will remain equal to this voltage. That's a virtual ground concept. Circuit is called as a current series negative feedback amplifier. You people can just copy it on the circuit diagram, and later we'll have a small derivation. We'll write the equation in the next slide. Take a minute. Now you copy down the circuit diagram. Take a few more seconds. We'll try to write equations. Take another 2-3 seconds or 10 seconds to note down. Hope these are visible to people. This is R1 and VF, VID, IB, VCC is the I0 plus Vin. So Vin and plus and minus, plus VCC minus VE. Hope all these are visible to you people. If something is not visible, let me show you with the zooming. So let us go to the next. Now writing a Kirchhoff's voltage equation for the input loop. What is the input loop, sir? Observe this carefully. I am talking about Vin and this input op amp VF R1. This is what I am taking. So those who didn't see, you please observe carefully. I am talking about this loop. Now I am going to write an equation for that. What is that equation? I just write down Vin equal to VID plus whatever is there, VF. But VID is equal to 0. Reason is A is very, very large. This is the concept of what you have discussed. And now therefore I can say Vin equal to VF and Vin equal to nothing but I0 into R1. And I0 is given by Vin by R1. This current is given by Vin voltage divided by R1. Why Vin, sir? Because virtual ground concept, these two voltages will be always equal to C because the gain is infinity. This we have discussed many times. Take a minute and copy down these 3 lines. Vin equal to VID plus VF but Vid equal to 0, therefore Vin equal to Vf, Vin equal to R1 into I0, I0 equal to Vin divided by R1. Diagram is with you already. Those who didn't copy properly, they can copy down now also. I'll show them. This is the same points. Hope most of you have copied this. Vin equal to Vf, Vin equal to R1 into I0, I0 equal to Vin by R1. Go back to the. Now, we know that I0 equal to Vin by R1. This means input voltage appears across the R1. Voltage will appear across whatever you are applying, it will appear across this. Hence, I0 equal to Vin divided by R1. Voltage to current converter can be used in low voltage DC and AC voltmeter, diode match finder, LEDs, some applications we are going to see after 2 slides. With grounded, with floating load, a lot of applications are there, but few will try to see the applications where it is useful, sir. 1 or 2 applications we will discuss. Now you just copy down names with the circuit diagram. We will discuss how these can be used. Voltage to current converter, how we can test the LED, how we can test the diode. Those things we are going to discuss. Take another few seconds and try to copy down. Let us go to the next. Okay, now so one simple question I want everybody to answer. Whether your answer is right or wrong is secondary for me. Be active. Let us discuss so that you can make a teaching learning more effective. You are in lab. There is a need to measure 6 to 10 volts, but the available meter can read maximum 6 volts. Is there any solution in your mind? What to do? Say I have A point, B point. So between A and B, I can measure maximum 6 volts. But actually the voltage in between A and B will vary from 6 to 10 volts. Then how to measure, give a solution, even though it is wrong, no problem. Either you can type or you can unmute, you can talk. You have a more than 1 minute time. Use your brain. This is a time for you people to use your brain. If you stop using your brain, later it will become a problem. It becomes a habit for you. I want you people to type, or no sir, I'll tell, no problem. First tell your name. Then you tell your concept, how it can be done. Give me a second. Now, how it can be done? We have spent a lot of time to discuss this. Thank you for all your answers. Few answers were wrong, few answers were a little correct. And now, this we have discussed voltage to current converter. And what I can do here, RL, load resistor, can be connected by directional meter movement. I think analog meter, how many of you used? Can you say yes if you have used analog meter? With a full scale deflection of 1 milliamp meter. That we are going to show in the next slide. Anybody has used analog meters? I think nowadays most of the students, they won't use analog meters, even in the lab also. But earlier we used to have only analog meters. So, yeah, okay, Pavan has seen the analog meter. Very good, you have used also. Very good. Rakshita has used. They may be a diploma student, some of the students. Ulvesh is diploma, I think, maybe. Ulvesh, are you a diploma student? You can say diploma if you can write. Seen in PU sir. Okay, Ibrahim has attended today's class but is active. And Ulvesh not a diploma. Thank you. And now let me go to the next circuit, and you people can take a minute or two and try to copy down this. I'll give you the 2 minutes. Then we'll have a discussion. Other than pin numbers, you can note down the circuit diagram. Okay, I'll wait for another 10 seconds. Then we continue our discussion. Offset voltage compensating network, all of you have know. What is the use of that? To make output voltage equal to 0 when the input is 0. Okay. External offset compensating network to null the output. This we have discussed already in detail. Now let us go to the next. I want answer in the chat box. What is the approximate resistance between the A and B? Hope it's visible to each one of you. Type your answers in the chat box. In terms of ohm, kilo ohm, you can type. I don't want exact using a calculator. And we have done it already. When we were discussing externally compensated this particular network RA, RB, RC, that time we have discussed. What will be the approximate resistance between the A and B? Okay, 1 kilo ohm, Sita, Ulvesh and Aditi has told 1 kilo ohm. ये 1 किलो ओम कहाँ से आ रहा है? यूं ही फेंक रहे हैं क्या आप सब लोग? 1 के कहाँ से आ गया? 1 के है ही नहीं इसमें. I don't know how you people, something you can say, even 15k plus something, sir. Okay, I noted some of the names I am not telling, otherwise everybody will repeat that answer. Okay, Rakshita 15k, somebody is 10 ohms, and yeah. Now answers are changing. 10 parallel with 2.5k, sir. How it will become 2.5? Vinayak Damodar, think on that. Yeah, 10 ohms. Now most of the students, they are telling, yeah sir, it is a 10 ohm. Very good. After a long time, my students are telling the answer. I am so happy. So our happiness depends on our students. So now, how come it is 10? Just try to understand. Somebody, let me go back to the slide. See, this is maybe the middle maximum resistance, and somebody told it will be a 2.5k, sir. 2.5k in series with the 15k, it will become 7.5k. 7.5k comes parallel with the 10k. 10 ohm, and 17.5k parallel with the 10 ohm. It comes around nearly equal to 10 ohm. This is one important point one should understand. And this is a basic fundamental which you have studied in your network analysis. And actually these we should not discuss. Tell you frank, these all we should not discuss. We assume equal to 10 in between A, B, then we should continue our discussion. We never spend a time to talk about A and B. Resistance is nearly 10 ohm. But we know our students where they will not understand, there only we spend a little more time, even though the circuit is very simple. Fraction of seconds are more than enough to understand, but sometimes a few students, they might have not attended the online classes, They might have enjoyed. They might have bluffed the teachers, and it is dangerous to the students. Remember, never try to tell or never try to bluff a teacher, lawyer, and a doctor. Remember, they are for you people. If you tell lie to the doctor, it is dangerous to you. You should not tell lie to the teacher. Even you should not tell lie to the lawyer, because they are for you people. They are doing something for you people only. If you tell lie, it is dangerous. Answer is correct. Most of the students, they told it is approximately equal to 10 ohms. Sir. Let us go to the next. Another few minutes we will continue. R1 equal to 10 ohm. Now the connection is this side. Hope it's visible to you people. Now 1K, this we have already discussed how it will become 10 ohm. 1K plus 10 ohm nearly equal to 1K. That will never impact. We consider these resistors only directly. If Vin equal to 1 volt, then I naught equal to Vin by R1, this equation we have already discussed. 1 volt divided by 1K will become 1 milliampere. And this means that 1 volt causes the full scale deflection of the ammeter. ये पूरा डिफ्लेक्शन हो जाएगा कब? Input 1 volt हो तो. And now you can copy down the 3-4 lines. R1 equal to 10 plus 1K is nearly equal to 1K. If Vin equal to 1 volt, then I naught equal to Vin by R1 equal to 1 by 1 kilo, it becomes 1 milliampere. Remember, this meter, whatever we discuss, a full scale deflection will be there when 1 milliampere goes inside or flow here. Whenever 1 milliampere is flowing here, it will show the full deflection. That's all. What you are measuring, we have to decide based on voltage what we are applying here. And what resistor I am connecting here. If I fix this 1 volt, then I have to change this resistor so that I can measure different voltages. We'll wait for another few seconds and then we'll go to the next. Similarly, let us consider if a rotary switch, I am changing the position and I have connected to the 10 kilo. So this is a 10 kilo. So that time 10 ohm plus 10 kilo ohm, it comes around 10 kilo ohm only. Now 1 volt is there. Therefore, it will require 10 volts input to get a full scale deflection, or you can say 1 milliampere. So hence, so to get a full deflection, now I have to give a 10 volts instead of 1 volt. The same meter now I am using to measure the 10 volts. Just copy down and try to understand. So if I want higher, if the higher the resistance, values are required to measure the higher input voltages. I don't know, previous you can just, I don't know, it's the same concept. If you want, you can copy down 1 or 2 lines. I will wait for a few seconds. Then I will go to the next. Okay, let me go to the next. Similarly, now I want you people to answer in the chat box. Similarly, instead of 13 kilo, if I connect 1K 1 volt, 2K 2 volt, 10K 10 volt, 13K it's a 13 volt. Can I connect a 20K so that I can measure this particular meter up to 20 volts? You can say either yes or no. Those who are online, they can type any one answer, yes or no. Answer may be wrong, no problem, I'll be happy to see your name. Can I connect? Okay, no. Majority are telling no. Okay, why can't I connect a 20K and measure up to 20 volts? Anybody would like to type an answer, one line answer? Thank you, Divya, Vishal, Pavan, Abhinandan, Preeti. Can you type a one line answer? No sir, maximum is 13 volts, Rohit Sheth. How can you say maximum is 13 because it's there in the book, or how? It's correct, maybe correct. Yeah, Rakshita has told. Max is, yeah, Rajat Rahikar has told something. Max voltage is a 15, sir. It's there in diagram, Baba, Rohit. Not in general, I am asking you. I can connect one more. No? See, I can remove 10K. I can connect 8. That time it will become 0 to 8. Got it? See, Totashri is typing. Because maximum what I am applying supply voltage itself is 15 volts. I cannot use the input voltage more than the supply voltage. This is a common sense. Because of the 15 voltage, he has stopped at 13 volts. It's not going more than that. Because plus or minus VSAT means I'll get a plus or minus 13.5 or 14 volts usually. I won't get more than 15 volts. Okay. So I think 2-3 students, they told the answer. Very nice. Thank you. Please remember this and you can copy down the last line that input voltage 20 volts. No, supply voltage is 15. Maximum input is you can give 14. Hence up to 13 is shown in the figure. You cannot give 20, 30 like that because supply voltage itself is a 15 volts. So note down this one point. Then we'll try to conclude today's class. Then we'll spend a little time with the discussion. Those who are having some points or at least those who are not getting emails, I would like to talk to them. Why they didn't join the classroom, because all the email IDs are taken from the classroom. Why they took more time to join the classroom. Hope most of you copied this. Yeah. Meter, a DC voltmeter with a full scale reflection of 1 to 13 volts can be constructed. Meter resistance does not affect IO. Meter resistance is very, very less, we assume. So I think this much we'll discuss. Applications we'll discuss in the next class because 3-4 applications are there. It will take 10 minutes. Hardly another 3-4 minutes we'll discuss general. Now I have completed the class and we'll conclude today's class here only. And those who are having doubts, you can talk to me. I'll be here only.